This program, FIRFILTSUB, shows how highpass, bandpass, and bandstop FIR filters can be created from the sums and differences of low-pass filters, high-pass filters, and constants. The top control allows you to change the filter type of both filters. Filters such as the Kaiser filter have parameters that can be specified with the additional slider and edit box that appear where appropriate. The two controls below, colored green and red respectively, determine whether each of the two filters is to be low pass, high pass, or whether it is to be a constant. The lower panel shows the magnitude of the two filters' responses plotted in green and red respectively. The blue curve is the difference of the two filters' responses. In this case, both the green and red filters are low pass, and the difference is a bandpass filter. Checking this box displays all the magnitudes on a log scale. The middle panel shows the impulse responses of the green filter, the red filter, and their difference, the blue filter. The parameters of the green and red filter are set with these controls here. The lengths of both filters are set with this slider or the edit box. The two sliders below, labeled omega 1 and omega 2 with their associated edit boxes, adjust the corner frequency of the green filter and red filter respectively. You can also adjust the corner frequencies directly on the magnitude plot by moving the little green or red triangles. Pressing the link icon between the two frequency sliders links the corner frequencies of the two filters, resulting in a filter of constant bandwidth. Dragging the center triangle here changes the center frequency of a constant bandwidth filter. Clicking in the magnitude plot brings up a cursor which shows the magnitude of the green curve, the red curve, and the blue curve, as well as the associated frequency. Pressing the green button or the red button isolates the response of only one of the filters and its associated impulse response. The blue button icon between these two buttons determines whether the green curves are subtracted, as they are here, or whether they are added, which would be a mistake here. Using this program, you can easily show how to create a high-pass filter from the difference of a constant and a low-pass filter, or create a bandstop filter from the difference between a high-pass filter and a low-pass filter. You can open a sound file, play it,
She sells seashells.
and play the filtered version.
She sells seashells.
After you've loaded a sound file, the critical frequencies appear below the axis here. Finally, after you've designed a filter, you can write it out to a file. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.